Let us solve the first question on Chinese Remainder Theorem. Okay, so using Chinese Remainder Theorem, find the positive x such that when it divided by 7, it leaves the remainder 3. And when it divided by 9, it leaves the remainder 6. And when it divided by 10, it leaves the remainder 5. Okay, so the statement problem is given and we have to write the simultaneous equation. Look here, when x is divided by 7, it leaves the remainder 3. That means x congruent to remainder 3 under the modulo 7, right? And x congruent to 6 modulo 9 and x congruent to 5 modulo 10. So we have to write the equation like this. Later we have to write the standard form of these linear congruences, which is x congruent to a1 and x congruent to a2 and x congruent to a3 modulo respectively m1, m2, m3. We can have the values of a1, a2, a3 and m1, m2, m3, right? After finding the value of m1, m2, m3, we have to calculate capital M. What is that? m1 into m2 into m3, right? So after find the value of m3, so after finding the value of capital M, we have to calculate the values of capital M1, capital M2 and capital M3. So capital M1, so capital M1 is given by capital M by M1, which is M2 into M3, which is 90, and capital M2 is 70 and capital M3 is 63. After finding these values, we have to calculate M1 inverse. How can you calculate M1 inverse? So we have to make use of what? These equations. M1 into M1 inverse congruent to 1 modulo M1 and for M2 and M3 like this, right? So let us substitute the value of M1, capital M1. So we have this value. Look at this. So here we have the equation. Okay. So the thing is, you have to take the calculator and do like this. Okay. So look here, we have 90 into M1 inverse congruent to 1 modulo 7. The very first thing is you have to start the value from 1. So let us substitute M1 inverse equal to 1. So what happens? So 90 into 1, which is 90, minus 1, and is that divisible by 7? Are you getting an integer? No. So it is not divisible by 7. So now let us substitute M1 inverse equal to 2. So 90 into 2, okay, minus 1. Okay, let us divide this by 7. No, it is also not divisible by 7. Fine. Let us substitute M1 inverse equal to 3. So 90 into 3 minus 1. Is that divisible by 7? Yes. No. So it is not divisible by 7. So we have to substitute M1 inverse equal to 4. 90 into 4 minus 1. Is that divisible by 7? No. And 90 into 5 minus 1. Is that divisible by 7? No. Let us substitute M1 inverse equal to 6. 90 into 6 minus 1. Is that divisible by 7? Yes. So we are getting an integer. So it is divisible by 7. So M1 inverse equal to 6. In a similar manner, we have to consider this. Okay. We have to consider this now. So here 70 into M2 inverse congruent to 1 modulo 9, right? So let us substitute M2 inverse equal to 1. So what happens? 70 minus 1, is that divisible by 9? No, we are not getting an integer, no. Let us substitute M2 inverse equal to 2. 70 into 2 minus 1, is that divisible by 9? No. Let us substitute M2 inverse equal to 3. 70 into 3 minus 1, is that divisible by 9? No. Let us substitute M2 inverse equal to 4. 70 into 4 minus 1, is that divisible by 9? Yes. So we here the answer is M2 inverse equal to 4, right? In a similar manner, we have to calculate this. We have to calculate this in a similar manner. So here 63 into M3 inverse is congruent to 1 modulo 10, right? So let us substitute M3 inverse equal to 1. So what happens? So 63 into 1 minus 1, is that divisible by 10? No, right? Again, let us substitute M3 inverse equal to 2. So 63 into 2 minus 1, Is that divisible by 10? No. Right? Let us substitute m3 inverse equal to 3. 63 into 3 minus 1. Is that divisible by 10? No. Let us substitute m3 inverse equal to 4. 63 into 4 minus 1. Is that divisible by 10? No. It is not divisible by 10. Let us substitute m3 inverse equal to 5. 63 into 5 minus 1. Is that divisible by 10? No. Again, 63 into 6 minus 1 divided by 10. So, no. 63 into 7 minus 1. Is that divisible by 10? Yes. So, m3 inverse equal to what? It is 7. Okay. So, m3 inverse equal to 7. So, after finding these values, we know the solution by the Chinese remainder theorem. So, let us substitute that. a1 into m1 into m1 inverse plus a2 into m2 into m2 inverse and plus a3 into m3 into m3 inverse under the modulo m. So, it is this one. So, we got this. And if I add them, so I will get 5505 modulo 630. So, what you have to do here in this case, you have to divide this 5505 by 630. What happens? 5505 divided by 630. So it is 8 point something, right? So you have to multiply 8 to 630. Okay, and you have to subtract this value with 5505. So it is 465. So x congruence to 465 modulo 630.